From concept to reality, how Helion's $5.4 billion investment is shaping the future of nuclear fusion technology. Introduction. Nuclear fusion has long been regarded as the holy grail of energy production, an ideal source of clean, virtually limitless energy. In a significant step towards realizing this potential, Helion Energy has recently secured $425 million in a Series F funding round, pushing its total investment over $1 billion and its valuation to approximately $5.4 billion. This report examines how Helion's latest funding, technological advancements, and commercialization efforts are positioning the company as a leader in the nuclear fusion landscape. Funding and valuation. On January 28, 2025, Helion Energy announced that it had successfully closed an oversubscribed Series F funding round which raised $425 million. This funding was backed by a mix of new and existing investors, including high-profile names such as SoftBank Vision Fund II and Lightspeed Venture Partners. The completion of this round has not only solidified Helion's financial standing but also increased its post-money valuation to $5.425 billion. Helion CEO David Kirtley expressed confidence in the company's trajectory, stating, "We are on the brink of delivering a transformative energy solution that can meet the world's increasing electricity demands while preserving U.S. energy leadership." The overwhelming interest from investors is a testament to the belief in Helion's ability to overcome scientific and technical challenges to commercialize fusion technology. Technological milestones. Helion has made significant strides in its technological development, most notably with its 7th-generation prototype Polaris. This prototype is expected to demonstrate the first successful generation of electricity from nuclear fusion, a critical step in proving the viability of fusion as a commercial energy source. Prior to Polaris, Helion's Trenta prototype reached a crucial milestone by achieving a fuel temperature of 100 million degrees Celsius, an essential threshold for commercial fusion applications. This achievement places Helion among the few private entities making notable advancements in fusion technology, setting the stage for the future of energy production. Commercialization efforts. Helion's ambitions extend beyond prototype development. The company is actively working towards commercializing its fusion technology. Plans are in place for Helion's first fusion power plant, which is set to be located in Washington state. In 2023, the company entered a power purchase agreement (PPA) with Microsoft, which will allow Helion to supply electricity from a 50 MW fusion plant starting in 2028. Additionally, Helion has a customer agreement with Nucor to develop a larger 500 MW fusion plant by the 2030s. These agreements illustrate Helion's commitment to transitioning from research and development to actual energy production. The collaboration with major corporations like Microsoft and Nucor not only validates Helion's technology but also showcases a growing interest in sustainable energy solutions among industry leaders. Industry impact. The ongoing investments and technological advancements position Helion as a frontrunner in the fusion energy race. Industry experts including Ravi Matre from Lightspeed Venture Partners have expressed optimism about Helion's potential to lead the transition to commercial fusion power. Matre remarked, "Fusion has the potential to be a truly transformational technology for industry and society, and we see Helion as leading the race to bring that technology to market." Helion's advancements in fusion technology could have far-reaching implications for the energy industry. If successful, fusion power could provide a clean, abundant energy source that significantly reduces reliance on fossil fuels, thereby addressing key challenges related to climate change and energy security. Conclusion. Helion Energy's recent funding and technological progress underline its ambition to pioneer the nuclear fusion landscape. With over $1 billion in total investments and the backing of prestigious investors, Helion is well positioned to transform how the world approaches energy production. The company's focus on developing safe, reliable fusion generators is not only a step toward meeting growing electricity demands but also a crucial move in the fight against climate change. As Helion continues to advance its prototypes and forge key partnerships for commercialization, the dream of harnessing fusion power may soon become a reality. The journey from concept to reality is underway. And Helion is at the forefront of this transformative energy revolution. Helion Energy is making significant strides in the nuclear fusion sector, recently announcing a substantial $425 million investment in a Series F funding round, which elevates its total funding to over $1 billion and its valuation to approximately $5.4 billion. This influx of capital has attracted interest from prominent investors, including the SoftBank Vision Fund and Lightspeed Venture Partners, underscoring a strong belief in Helion's potential to reshape the clean energy landscape. Key developments: 1. Funding and valuation. Helion's funding round, revealed on January 28, 2025, was oversubscribed, indicating robust investor enthusiasm. The company's post-money valuation reached approximately $5.425 billion. The support from established investors acts as a critical endorsement of Helion's advancements in fusion technology. CEO David Kirtley articulated the company's mission to develop fusion generators that are both safe and reliable, addressing the increasing demand for electricity. 2. Technological milestones. Progress in prototype development is notable, particularly with the 7th-generation prototype Polaris, which is anticipated to showcase electricity generation from fusion. Helion's previous prototype Trenta achieved a milestone by reaching fuel temperatures of 100 million degrees Celsius, a crucial requirement for commercial fusion applications. 3. Commercialization efforts. Plans for Helion's first fusion power plant are set for Washington, with agreements established with major corporations. A power purchase agreement (PPA) with Microsoft aims to provide electricity from a 50 MW fusion plant beginning in 2028, while a partnership with Nucor focuses on developing a larger 500 MW plant in the 2030s. 4. Industry impact. The combination of investment and technological advancements positions Helion as a frontrunner in the quest to deliver fusion power, which is seen as a transformative energy solution. Industry experts such as Ravi Matre from Lightspeed Venture Partners have expressed optimism about Helion's path toward commercialization. Counterintuitive information. High valuation amidst historical challenges. The substantial valuation of $5.4 billion may seem counterintuitive given the historical challenges faced by nuclear fusion technology, often regarded as the holy grail of clean energy. For decades, fusion has been plagued by technical hurdles and has failed to deliver commercially viable energy solutions, leading many to be skeptical about its future. However, Helion's recent successes may indicate a turning point, suggesting that technological advancements could finally enable practical fusion power. Investor confidence versus market reality. While the overwhelming investor confidence in Helion reflects optimism about the future of fusion, it contrasts sharply with the broader market skepticism about the feasibility of fusion energy. Many traditional energy stakeholders remain cautious, emphasizing the long timelines and significant R&D required to realize commercial fusion plants. Despite Helion's promising prototype advancements, fusion as a transformative technology. The characterization of fusion as a transformative technology is somewhat counterintuitive, given that it remains largely unproven on a commercial scale. While fusion holds the potential for abundant clean energy, significant technical, regulatory, and infrastructure challenges must be addressed before it can truly transform the energy landscape. Conclusion. Helion's remarkable investment in technological advancements highlight its ambition to lead in the fusion energy sector. With substantial backing from high-profile investors and notable milestones in prototype development, Helion is well-positioned to potentially revolutionize energy production, offering a viable and sustainable alternative in the global effort against climate change. The juxtaposition of investor enthusiasm against historical skepticism towards nuclear fusion underscores the complexity and unpredictability of technological innovation in energy. In the report on Helion Energy's recent funding and its implications for nuclear fusion technology, Several important aspects may be overlooked, yet they hold significant implications for the future of energy production and environmental sustainability. Significant aspects to note. 1. Oversubscription of funding. The $425 million Series F funding round being oversubscribed is not just a financial statistic, it indicates a strong market confidence in Helion's potential to succeed. This confidence stems from the understanding that Helion is not merely developing a theoretical technology but is actively moving towards commercialization. Investors' willingness to commit additional funds demonstrates a collective belief in the viability of fusion as a practical energy source, which is crucial for attracting further investment and support in the energy sector. 2. Technological milestones and their implications. Helion's achievement of reaching a fuel temperature of 100 million degrees Celsius with the Trenta prototype is a critical milestone that is often overshadowed by broader discussions of funding and investment. This temperature is significant because it is the threshold required for achieving net positive energy output in fusion reactions. The ability to reach and maintain such temperatures not only showcases Helion's technical prowess but also highlights the potential for practical application in energy generation. Successfully demonstrating electricity generation with the Polaris prototype could serve as a turning point for fusion energy, marking the shift from theoretical discussions to tangible energy solutions. 3. Strategic partnerships and agreements. The agreements Helion has entered into with major corporations such as the Power Purchase Agreement (PPA) with Microsoft and a customer agreement with Nucor are pivotal. These partnerships not only provide a clear pathway for commercial viability but also signify an industry-wide shift towards embracing fusion as a credible energy source. By aligning with established corporations, Helion is not only securing financial backing but also leveraging the operational expertise and market reach of these partners. This aspect is significant because it demonstrates a collaborative approach to overcoming the challenges associated with developing and deploying new energy technologies. 4. Location of the first power plant. Helion's decision to site its first fusion power plant in Washington is also noteworthy. The choice of location can influence regulatory, logistical, and community acceptance aspects of the project. Washington has a history of supporting clean energy initiatives, which could facilitate a smoother approval process and public support. Furthermore, the location's existing infrastructure could be advantageous for technology deployment. The significance of this decision lies in its potential to serve as a model for future fusion projects impacting regional energy policies and economic development. 5. Environmental and societal impact. The report emphasizes Helion's mission to provide zero-carbon electricity from fusion, which is critical in the context of global climate change challenges. However, the societal implications of successfully deploying fusion technology are substantial. If Helion can deliver on its promise, it could lead to a paradigm shift in how society approaches energy consumption and production. Fusion energy could provide a nearly limitless source of clean energy, drastically reducing reliance on fossil fuels and mitigating environmental degradation. This aspect is often underrepresented in discussions focused solely on financial and technical milestones. 6. Broader implications for the energy sector. Helion's advancements in fusion technology could catalyze a wider shift in the energy sector towards innovative solutions. The confidence shown by high-profile investors may encourage more research and development in fusion and other alternative energy sources. This could lead to a competitive environment where technological advancements accelerate, ultimately benefiting consumers with more diverse and affordable energy options. Understanding this potential ripple effect is crucial for grasping the full significance of Helion's progress. Conclusion. In summary, while the report provides a comprehensive overview of Helion Energy's funding and technological advancements, the overlooked aspects such as the implications of oversubscription, strategic partnerships, and the environmental impact of fusion technology are equally vital. These elements not only underscore Helion's potential to revolutionize energy production but also highlight the broader societal and environmental benefits of advancing nuclear fusion technology. Recognizing these factors is essential for stakeholders across the energy landscape, policymakers, and the public as they navigate the transition towards sustainable energy solutions. 1. Significant financial backing and valuation. Helion Energy's recent $425 million Series F funding round, which brings total investments to over $1 billion and values the company at approximately $5.4 billion, highlights the strong investor confidence in the potential of nuclear fusion technology. High-profile investors including SoftBank Vision Fund 2 and Lightspeed Venture Partners not only provide financial resources but also lend credibility to Helion's mission of developing reliable and safe fusion generators. This significant financial backing signals a pivotal moment in the quest for clean energy solutions, as it enables Helion to accelerate its research and commercialization efforts in a field that has historically struggled for funding and successful implementation. 2. Advancements in fusion technology. Helion's technological milestones, particularly with its 7th-generation prototype Polaris, are crucial for the future of fusion energy. The achievement of a fuel temperature of 100 million degrees Celsius with the previous Trenta prototype is a critical benchmark that aligns with the operational requirements for commercial fusion power. This technological progress is essential for demonstrating the viability of fusion as a practical energy source and is a key factor in attracting investment and developing public interest in fusion energy. The ability to produce electricity from fusion is a transformative step that could redefine energy generation. 3. Strategic commercialization efforts. Helion's agreements with major corporations, such as the power purchase agreement with Microsoft for a 50 MW fusion plant and plans for a larger 500 MW plant with Nucor, illustrate a clear path towards commercialization. The strategic siting of their first fusion power plant in Washington and the collaboration with well-established companies emphasizes Helion's commitment to integrating fusion technology into the existing energy market. These partnerships are instrumental in testing the market readiness of fusion energy and in establishing a framework for future commercialization, helping to drive innovation and adoption of fusion technology in the energy sector. 4. Potential industry impact and leadership. Helion is positioning itself as a leader in the burgeoning field of fusion energy, which is often referred to as the holy grail of clean energy. The ongoing investments and technological advancements from Helion, along with the strong endorsements from industry experts, suggest that the company could play a pivotal role in addressing global energy challenges. The potential for fusion to provide limitless clean energy aligns with the growing demand for sustainable energy solutions and can significantly contribute to combating climate change. Helion's success in this endeavor could not only transform the energy landscape but also inspire further investments and innovations in fusion technology, fostering a new era of energy production. 1. The Manhattan Project 1942–1946. The Manhattan Project was a research and development undertaking during World War II that produced the first nuclear weapons. Initiated in response to fears that Nazi Germany would develop atomic bombs, it brought together some of the world's leading scientists, including Robert Oppenheimer, Enrico Fermi, and Richard Feynman. The project culminated in the successful detonation of the first atomic bomb in July 1945 in New Mexico, followed by the bombings of Hiroshima and Nagasaki in August of that year. The Manhattan Project not only marked a significant advancement in nuclear physics but also ushered in the nuclear age with profound implications for warfare, energy, and international relations. 2. The Apollo Program 1961–1972. The Apollo program was a series of space missions conducted by NASA with the primary goal of landing humans on the Moon and safely returning them to Earth. Initiated by President John F. Kennedy's call for a lunar landing by the end of the 1960s, the program involved extensive technological innovation and collaboration among thousands of scientists, engineers, and astronauts.
The program successfully achieved its goal with Apollo 11, which landed astronauts Neil Armstrong and Buzz Aldrin on the Moon in July 1969.
The Apollo program not only advanced space exploration but also had lasting impacts on technology education
and international cooperation in science.
3. The development of the Internet 1960s present. The development of the Internet can be traced back to the 1960s when the U.S. Department of Defense funded research into networked communication. The ARPANET, which became the first operational packet switching network, was established in 1969. Over the decades, various technologies and protocols were developed, leading to the expansion of the Internet beyond military and academic uses to the general public in the 1990s. This transformation has reshaped communication, commerce, and entertainment worldwide, highlighting the Internet's role as a catalyst for societal change and innovation in modern life. These cases illustrate how significant investments, technological advancements, and collaborative efforts can lead to groundbreaking developments that reshape industries and have far-reaching impacts on society. Future outlook, predictions for Helion Energy and nuclear fusion technology. Helion Energy's recent funding achievements and technological advancements position it as a pivotal player in the nuclear fusion sector. As we look to the future, several key predictions can be made about the trajectory of Helion and the broader implications for nuclear fusion technology.
1. Commercialization of fusion power by 2030. With the successful operation of its 7th-generation prototype Polaris, Helion is on track to demonstrate electricity generation from fusion. By 2030, it is anticipated that Helion will have its first operational fusion power plant, potentially delivering significant amounts of clean, reliable electricity. The company's agreements with Microsoft and Nucor signal a commitment to scaling up production, which is essential for achieving commercial viability. 2. Increased investment and market growth. As the global demand for clean energy rises, investment in fusion technology is expected to surge. Helion's recent funding round, oversubscribed and backed by prominent investors, sets a precedent for future capital influx into the fusion sector. This trend will likely attract other venture capitalists and institutional investors, further accelerating technological advancements and commercialization efforts across the industry. 3. Technological innovations and efficiency improvements. Helion's ongoing research and development will likely lead to significant technological breakthroughs. Improvements in plasma confinement and stability energy extraction methods and reactor design are expected. These innovations could reduce the costs associated with building and operating fusion reactors, making fusion a more competitive alternative to traditional energy sources and other renewable technologies. 4. Policy and regulatory support. Governments worldwide are increasingly recognizing the potential of fusion as a clean energy source. As the urgency to address climate change escalates, we can expect more robust policy frameworks and incentives aimed at fostering fusion research and development. Regulatory bodies may streamline approval processes for fusion projects, facilitating quicker deployment of commercial reactors. 5. Global collaboration and knowledge sharing. The complexity of fusion technology necessitates collaboration across countries and research institutions. As Helion advances toward commercialization, it is likely to engage in partnerships with other entities, fostering a collaborative ecosystem. This global network will enhance information sharing and accelerate problem solving, enabling faster progress in the field of fusion energy. 6. Disruption of energy markets. The successful deployment of fusion technology has the potential to disrupt traditional energy markets fundamentally. By providing a near-infinite source of clean energy, fusion could reduce reliance on fossil fuels, thereby impacting oil and gas industries significantly. As fusion becomes more prevalent, we may see a shift in energy pricing structures, leading to lower energy costs and increased energy security. 7. Public perception and acceptance. Public perception of nuclear energy has evolved over the years, particularly with advancements in safety and sustainability.
Helion's emphasis on developing safe, reliable fusion energy will likely contribute to greater public acceptance of nuclear technologies. Educational initiatives and transparent communication regarding the benefits of fusion could further enhance its acceptance as a mainstream energy source. 8. Integration with other renewable technologies. As the world moves toward a more sustainable energy future, fusion will likely be integrated with other renewable technologies such as solar and wind. This hybrid approach could enhance energy reliability and grid stability, allowing for a more resilient energy infrastructure. Helion's advancements may pave the way for innovative energy solutions that leverage the strengths of multiple energy sources. 9. Long-term sustainability and environmental impact. The shift to fusion energy is anticipated to have profound implications for sustainability. Fusion produces minimal waste compared to fission and has the potential to significantly lower carbon emissions. As Helion and other companies continue to develop fusion technology, we can expect a substantial contribution to global efforts in combating climate change and promoting sustainable energy practices.
10. A new era of energy production. Ultimately, Helion's trajectory represents a shift toward a new era in energy production. As fusion becomes a practical reality, it may redefine energy paradigms, offering a solution to the world's escalating energy demands while addressing environmental concerns. The successful rollout of Helion's fusion technology could mark the beginning of a transformative chapter in global energy history. Conclusion. The future of nuclear fusion technology, spearheaded by Helion Energy, appears promising and filled with potential. With continued investment, technological advancements, and supportive policies, Helion is well positioned to lead the charge in making fusion power a viable and sustainable energy source. The coming decades will likely witness significant changes in the global energy landscape, driven by the successful commercialization of fusion technology.